Good afternoon. Today we will make a geomechanical model in terms of sand production prediction for example wells. And the first step is please open the test project that is attached to the guide. Okay. You will see 5 wells in the project that we will use for our work. After that, we need to download the arrays parameter in the project. To do it, please open Import Curves Array and click twice on the Excel file with arrays. After this, you will see the dialog window in which we need to select all parameters for further importing in the project. To do it, please click Import All Data, and the first row is the name of the columns. Please set the value unit as minus 999.25. After this, click Recognize. You will see the next columns in which we need to compare the supposed columns and real parameters. In first column, please click Well. After this, date and type of date, date to date, month, year. Pore pressure gradient will be a parameter in which a curve array name will PPG, category is pressure and stresses, type is PPG, pore pressure gradient type, depth MD. Depth MD we will select after this operation. The bottom hole pressure is the same, it will be a parameter. Curve array name will be BHPG, category is pressure and stresses, type is bottom hole pressure gradient, unit gram for cubic centimeter. After this, we need select MD, measure depth, and select depth unit as meter. Let's return into the settings of pore pressure gradient and select depth MD, and also we need make this in the bottom hole pore pressure gradient column. Let's check again all importing parameters. And after this, click OK to download all arrays into the project. The information about downloading of parameters you will see in this slow toolbar. And after this toolbar will answer that loading curve array from file is completed. Please check that in each well the PPG and BHPG arrays were downloaded. The next step is creating of well section to visualize all necessary input parameters from sand production prediction. The first step is opening of casing on the well section, stratigraphy, and PPG and BHPG arrays. After visualization of PPG and BHPG on the well section, please click on the triangle and launch the player. Player will show you changing of arrays through the time and the changes you can see in each 1 year. Since 2009 until 2041. Let's make the same well section for another well using template manager. Please open the well section. After this template manager, and track tab and click on the track casing and create test casing. After this, click stratigraphy, create test stratigraphy, and click on the track number 3 with erase PPG and BHPG and click create test erase. After this, save. After this, click to well. Click select all, save. And the arrays were paired for all wells. Delete not necessary track for SV04. After this, click two wells again. Clear well sections before applying template no, and switch off the SV04 because this well is already used for template. After this, save. Not this. Let's delete these tracks and click on the test strat, two wells, clear well section before applying template no, and click well, save. Yes, and make the same for casing, test casing, two wells, no, and well, save. Okay. After this, click right button of mouse and click organize track by wells. Let's rearrange the parameters. Casing must be first, stratigraphy must be second, and erase must be third. And let's check what's happened with well number SF 54. Click erase two wells, no, and click only by SV 54, save. Yeah, after this the problem was solved, and we can see the ready well section for 5 reference well with input arrays. Please click save project. The next step is creation of interval correlation line, and to do it, open data, interval correlation, and click wells icon. Please click all wells, and now please click plus for all wells with tops. Okay, tops, plus, tops, plus, tops, for all wells. Now click after correlation and please delete unnecessary correlation line from L6 to L14. To do it, click these correlation lines into the table and click delete. Okay. After this, click close and save correlation. To open the correlation, please click right button and well section properties. After this, switch on correlation. Also, we can make the correlation in TVD domain, and also we can click twice on the correlation and select flatten on the top. For example, flatten on the L1 top, or seal, or L2 or L3, L4, etc. Let's make for seal. Yes. Do you want save correlation? Yes. Now let's check the color of stratigraphy for well 22, 28 and 54. Please click filter icon and strat. You will see all stratigraphy column for all wells. Click on the SV22 and select layer color green, and make the same for another wells. SV28, save, and SV54, save. The next step is calculation of stresses, and to do it we need to first save project, and after this open the geomechanics tab and click on scenario. Scenario, this is workflow for automatic calculation of necessary amount of wells. Please click all wells for calculation and click stresses, horizontal stresses master. Click on calculation method poroelastic model and select all necessary input parameters for calculation, especially PPG. It must be massive, it must be array, static Young modulus, static Poisson ratio, epsilon h and epsilon h small. We will not calculate total minimum horizontal stress, but only minimum horizontal stress gradient. After this, please click save and make duplicate of this master and click twice on the duplicate. Please click on the SHMax. The calculation method must be the same, PPG is the same, and another parameters must be the same too. Okay. After this, click save and please check that first calculation will be for SHMean and second calculation will be for SHMax, and the parameters for both parameters should be the same. After this, we need to rename the scenario name and make prefix scenario sent and click override data and save a workflow scenario in the tree. This scenario will be here. Close and let's make launch. We can see that for all wells the SH-min and SH-max gradient were calculated. Let's check it. SV04 good, SV05 good, SV22 good, SV28 good, and the final SV54 good too. Let's make visualization of calculated SH-min and SH-max gradient arrays on the well section. To do it, please move SH-min and SH-max for each track of each well. Now let's make filling between curves to make understandable visualization. Please click on the middle button of mouse and set minimum and maximum as 0 and 3 with step equal 1. After this, click on the right button and select fill. Please create new filling and click curve constant, and curve will be PPG. The next filling will be a curve constant 2, but the curve will be SHG and constant will be 3, and fill color will be violet. Also, let's make changing of color for array of SH-max. Let's make it black. Okay. After this, let's click on the template manager and click on track and test arrays. After this, click update. Yes. And let's update all tracks for rest wells. Please click 2 wells, no, and let's click on the this and this well. After this, save. And we can see update tracks on this well section. Let's make the tracks, update tracks with their wells, and delete unnecessary tracks. Okay, as you can see that we have already updated all wells, and click the button to launching the player. And after this you can see the changing of minimum and maximum horizontal stresses due to stress path effect through the time. Please don't forget save the project. The next step is calculation of sand production prediction. To do it, click twice again on the saved scenario sand and please open a new parameter, sand production. Let's click on PPG for gating of array, the same for SHG and SHG minimum. And make the same for BHPG. All another parameters must be without changings. Save scenario and run scenario. The status of calculation of sand production prediction you can see in the lower toolbar. Please check that all calculation parameters you can see in the tree, in each well. Please check all wells. After this, let's make visualization of sand production prediction parameters on the well section. And at first, let's open these parameters SVG sand on this track. Okay, and check the minimum and maximum values. After this, let's make visualization of space between SVG sand and PPG. BHPG. To do it, let's open fill, create new fill, curve, and curve 1 will be SVG sand, curve 2 will be BHPG. From curve 2 to curve 1, and it will be yellow color with sand texture. Okay. The next that we need to do, open the SAF. This is sand production potential on the next track, and show on this track also UCS as strength parameter. And let's make the same minimum and maximum values from 0 to 200 with step 50. Okay, and let's make visualization between UCS and SAF. In case when SAF will be more than UCS, that means that it will be a paired sand production. Fill, curve, SAF and UCS. Fill color will be yellow with sand texture. and increment method curve 1 to curve 2. Sorry, vice versa. Yeah, good. And after this, let's make visualization of sand flag. It calls as sand potential. It's discrete curve that equal 0 or 1 depending on sand production appearance. And let's make filling of this. At first we need to click it on data properties and make minimum and maximum 0 and 1. Filling, new fill, curve constant, curve sand potential. Fill color will be yellow with texture sand. And returning to data properties, we need to make line properties as yellow. And let's check each time step. If we will change time step, we can see that in the intervals where SAF more than UCS, we can see the sand, and this can be visualized by sand flag. And also the next track will be CDP, critical drawdown pressure. This is maximum allowable critical drawdown pressure to avoiding of sand production. Okay, let's make the same for another wells. To do it, let's use the template manager and let's go on template manager. Let's click on the track with combined pressure gradients, and test array must be updated. Yes, update. After click next track and make create new template, test SIF. Save. Next track, create test sand flag. And next track, create test CDP. Okay, and first will be track test arrays. 2 wells, no, and all rest well. Save. Please make updated tracks near the well and delete unnecessary tracks. The next with SAF template, click on SAF template and click to wells. Clear, no, save. And make SAF tracks near the well. The next is send flag to wells, no. And the same with CDP. Now let's check all wells. First well SV04, second well SV05, third well SV22, fourth well and fifth well. Now it's good. Okay. And using this well section, we can check which year, in which year will appear on send production for each offset well. And it's a very convenient tool for estimation of time of send production prediction for any well. For example, in 2021 year, this interval, in this interval there will be appear send production. And by the time send production increased, as we see here. To make report of this work, we can open send production table, click all necessary well, and make a report in any convenient for us type. For example, stratigraphy time, stratigraphy wells, etc. Let's make any report. We can see in this report the wells and this the layer. And what we can see here, for example, in well SV04, sand production will be appeared in 2036 in layer 3 in these intervals. At this time, in the SV05, sand production will occur in the 2018 in this depths. For example, let's make another type of visualization of report. Time, stratigraphy time, generate table, and we can see, for example, times when occurs the sand production. And let's visualize the number of well. What we can see here? We can see here that, for example, in L1 layer in 2018, the sand production prediction will occur only in SV05. Okay, and at the same time, for example, in this layer number 4, in 2035, the sand production prediction will be in SV04, SV22, SV28, and SV54. We can make copy or export on this data in any convenient for us format. Okay, thank you for attention.